Now we're going to move on to our trig unit. And here are some specific facts that we want to recall from geometry. An angle is made up of an initial side and an ending side. We start measuring from the x-axis, and if we have a positive angle, we are going in the counterclockwise direction. If we have a negative angle, we are going in the clockwise direction. Angles that have the same initial and terminating sides are called coterminal. All coterminal angles are 360 degrees apart. Positive angles move counterclockwise, negative angles rotate clockwise. I've already stated that. And in terms of angles, if we have complementary angles, there are two positive angles that add up to 90 degrees, and supplementary angles are two positive angles that add up to 180 degrees. Key is that they're going to be positive angles. A new concept we're going to be looking at is a radian. And specifically, a radian is a unit of angle measurement. You've used degrees a lot. And the best way that I can equate a radian is that a radian and a degree are sort of like Celsius and Fahrenheit for temperatures. They both do the same thing, they're just different ways of measuring the same thing. Celsius and Fahrenheit both measure temperature. Degrees and radians both measure angle measurements. The way we find a radian is if we've got an angle on a circle, the radius of the circle, so right here you can see the radius, is how far we go around on the circle. So whatever this distance of the radius is, that's the distance we go around the circle, and we end up with 1 radian. A couple of facts that we want to have about radians is that every revolution around the circle is 2 pi radians. That means if I go halfway around the circle, I've got pi radians. A quarter of the way around the circle is pi over 2 radians, and 1/6 is pi over 3 radians. If we look at this from the degree perspective, 2 pi radians would then be 360 degrees, since that's a whole time around the circle. Half a revolution around the circle is 180 degrees. A quarter of the way around the circle is 90 degrees. And then 1/6 around the circle is going to be 60 degrees. So knowing that relationship is really important, that 2 pi radians is 360 degrees, pi radians is 180, pi over 2 is 90, pi over 3 is 60. And the best way we can convert between degrees and radians is to use the fact that every half revolution is pi radians or 180 degrees. So if I'm going to convert degrees to radians, I'm going to multiply by pi radians over 180 degrees. If I'm going to go radians to degrees, we're going to multiply by 180 degrees over pi radians. So let's see a couple examples of this. Converting degrees to radians and radians to degrees. I've got 156 degrees, and I want to know what that is in radians. I'm going to multiply by pi radians over 180 degrees. Now, what that allows me to do is my degree symbols cancel, and I'm left with 156 pi radians over 180. And if I reduce that down, that's 13 pi over 15 radians. So 156 degrees is the same thing as 13 pi over 15 radians. And that sort of makes sense when we think about it. Knowing that 180 degrees is pi radians and 156 is slightly less than 180, it would make sense that the amount of radians is going to be slightly less than pi. The second example, negative 325 degrees. If I want to convert that to radians, same idea. I'm going to multiply by pi radians over 180. My degrees cancel out, so I'm left with negative 325 pi radians over 180. And once again, that reduces to negative 65 pi over 36. radians. That negative makes no difference in terms of our formula. That just indicates that we're going in the counterclockwise versus the clockwise direction, the positives and negatives. The third example, we're going now radians to degrees. So I've got 7 pi over 2 radians, and I want to convert that to degrees. I would rewrite this as 7 pi radians over 2. And since we're going radians to degrees, we're going to use 180 degrees over pi radians. That way my pi and my radians cancel out. Over here the 2 and the 180 reduce to 1 and 90. So I end up with 630 degrees. So 7 pi over 2 radians is the same thing as 360 degrees. The last one here we want to look at is 3 radians. And we want to be careful on this because there's no pi in it. It's just 3 radians. So as we multiply, we're still going to use 180 degrees over pi radians, but here only the radians cancel out. I still have that pi down here. So when I multiply all this out, my exact answer in terms of degrees is 540 degrees divided by pi. But for an approximation, we can divide pi in, and we'll see that we get approximately 171.89 degrees. So 3 radians is 171.89 degrees, and that's that.